Good morning, good afternoon, or good evening. Welcome to today's webinar. My name is Alagapan. I am a Senior Account Manager with Amazon Web Services working out of Singapore. In this webinar, we will have an introduction to cloud computing with Amazon Web Services. This webinar is 101 level, so it is aimed at audiences who are new to these topics. So housekeeping. Let's first take a look at some of the housekeeping items. The presentation will roughly run for 45 minutes. During the presentation, you can post questions using the chat system. Our solution architects are online and will answer as many questions as they can. And do not forget to fill in the survey. We love customer feedback as it enables us to iterate and improve our services. Today's agenda. Here's the agenda for today's webinar. First, we will have a quick introduction to Amazon Web Services, followed by the benefits of using cloud and AWS. After that, we will take a look at services offered by AWS, as well as some of the typical use cases. To wrap things up, we will take a look at some of the strategies companies are following to get started with AWS. So without further ado, here is introduction to AWS. AWS provides broad and deep services to support any cloud workload, which means practically any workload. At the core are the compute, storage, and data services that are at the heart of our offering. We then surround these with a range of supporting components like management tools, networking services, and application services. All these capabilities are hosted within our global data center footprint that allows you to consume services without having to build out your own facilities or procure hardware equipment. AWS Pace of Innovation. This view shows the number of new services and features that were launched since AWS started. The pace of innovation at AWS is very quick and it's accelerating. Just last year alone, in 2013, we announced 280 new services and updates. AWS follows a lean and agile product development practices and innovates rapidly to serve our customers better. These innovations are both useful new services as well as features and enhancements requested by our customers. AWS Global Infrastructure. Our data footprint is global, spanning 5 continents with highly redundant clusters of data centers in each region. Our footprint is expanding continuously as we increase capacity, redundancy, and add locations to meet the needs of our customers around the world. Currently, we have 10 cloud regions with multiple availability zones in the regions. This allows our customers to deploy their applications and store their content across multiple data centers and fault isolation zones. We also have 51 edge locations which provide our CloudFront content delivery network as well as our Route 53 managed domain name service. AWS is solving problems for big enterprises across many verticals and geographies. We're extremely proud of our customer list and happy to know that we are providing good outcomes and better results for some of the best companies around the world. AWS is used by over 600 governmental agencies and over 2,400 educational institutions worldwide. These range from NASA JPL to the City of Melbourne and many others. Our premier tier partners are the top consulting partners globally. They have invested significantly in their AWS practice, providing exceptional customer service and helping a large number of customers run their applications on top of AWS. In addition to these, The AWS Partner Network has a large number of local partners who can help you started with your journey to the cloud. Now, we will move on to look at the benefits of using AWS. Security is a #1 priority for AWS. You might have questions about security in the cloud, but our biggest and most conservative customers have found that we are able to meet their security requirements, and often we can provide a better security profile than what they can deliver internally. The AWS Cloud Infrastructure has been designed and managed in alignment with regulations, standards, and best practices, including PSI DSS, SOC, and ISO 27001. Recently, we announced AWS CloudTrail, a service that records API calls made on your account and delivers log files to your Amazon S3 storage bucket. CloudTrail provides increased visibility into AWS user activity that occurs within an AWS account and allows you to track changes that were made to AWS resources. This allows enterprises to run comprehensive security analysis and better manage their governance and compliance efforts. Cost is the conversation starter when it comes to cloud. There are many pieces to cost conversation when it comes to AWS and your own infrastructure. The first advantage you get in the cloud is that you don't have to lay out capital expense for hardware and infrastructure before you know the demand. In essence, you convert your capital expense into variable expense. And then that variable expense on AWS is lower than what most companies can do on their own, because AWS runs at a massive scale, and we pass that scale to our customers, or we pass the benefit of that scale to our customers in the form of lower pricing. We have lowered our prices 41 times since we started in the absence of any competitive pressure. There are multiple pricing models in AWS, so you can optimize your spending on what workloads your requirements are. And the more you use AWS, the less your costs are. We have tiered pricing, and for customers doing large data center migrations, we have negotiated custom pricing to make their transitions cost effective. AWS has many purchasing options to support different technical and business needs. With our free tier, you can also try AWS easily, and you can run an initial evaluation of several AWS services. You can launch new applications, you can test existing applications in the cloud, and you can get hands-on experience, or get your hands dirty. With on-demand purchase option, you pay for compute capacity by the hour. This is an ideal option for development and testing on spiky workloads with irregular peaks. The third option is a reserved instance purchase option, and you can get a significant discount on the hourly charges compared to an on-demand price with a low one-time upfront payment. The overall savings can be up to 65% over equivalent on-demand capacity. Reserved instances, or RIs, are perfect for stable base workloads which you know will be running for a long period of time. The fourth purchase option is the spot instances. Spot instances allow you to name your own price for EC2 compute capacity. You simply bid on spare EC2 capacity, and then you can run these instances whenever your bid exceeds the current spot price. The current spot price varies in real time based on supply and demand. It's basically a marketplace. The spot instance pricing model complements the on-demand and the reserved instance models, providing you with potentially the most cost-effective option for obtaining compute capacity. Spot instances are best suited for distributed, interruption-tolerant workloads, such as batch processing, and processing a batch of when the price is right, or large-scale simulations. Using Spot, you can simultaneously speed up your time to results while at the same time lowering your costs. Finally, we have dedicated instances. Dedicated instances are intended for workloads with high regulatory compliance requirements. Dedicated instances run within your VPC or virtual private cloud on hardware that is dedicated to you. So only your instances will be running on the same underlying physical servers. Over the years, we and our customers have come to the realization that the #1 benefit of the cloud is increased business agility or increased speed. Enterprises cannot afford to be slow, but if you can ask an enterprise leader as to how long it takes for them to get a server for running a workload, the typical time frame is 10 to 18 weeks. In the cloud, you can spin thousands of servers in minutes and experiment quickly. Once the experiment is over, or the experiment does not work out, you can spin down these instances and stop paying for them. So there is a big difference compared to the old world. In the cloud, you can instantly spin up and spin down clusters, petabyte-sized data warehouses, and new production or development environments in a few minutes. Everything changes with this kind of agility. We see our customers doing amazing things when they reduce the cost of experimentation. It moves IT from being a roadblock where each idea costs a lot of money and takes a lot of time to IT being an enabler where you can launch a speculative project quickly and cheaply. This allows companies to take more chances on ideas and gives them a shot at winning big as opposed to being scared to even try. Now that we've looked at the benefits, let's take a look at the services offered by AWS. Now, I know this is a busy slide, but this is a very high-level view of our offerings. At the core, we have our foundational services, such as compute, storage, networking, and databases. These are the basic building blocks of cloud infrastructure. Interestingly, they're also the low-level primitives on which higher-level services are built, such as our application services. These comprise of, for example, simple email service, simple notification service, queuing services, video transcoding, and search engines. The application services are great enablers for building service-oriented applications on the cloud. By leveraging them, you can offload useful functions such as message queues to fully managed, reliable service. On the top, we have deployment and management services ranging from monitoring to application lifecycle management to user identity and access management. All the user interactions with the cloud services leverage our APIs or application programming interfaces. In other words, the cloud is a set of programmable data centers where all of the functionality can be accessed and provisioned programmatically. Users can interact with these services in several ways using our web console or command line interfaces or directly from their application code, leveraging our libraries and SDKs for different languages and client devices. So now let's take a closer look at each of these different tiers. Let's first start with compute. Compute is provided by our EC2 or Elastic Compute Cloud. It allows you to deploy virtual servers or instances. You will get the capacity in minutes, and you can run any x86-based operating system on these instances. Autoscaling is a perfect partner for EC2. The cloud is elastic, providing as much capacity as you need when you need it. This allows you to scale up your system to meet its demand, but also, equally importantly, scale it down when the usage is lower, such as in night times. Scaling down means releasing back some of the resources that are no longer needed, which lets you save cost. Basically, autoscaling allows you to right-size your environment and make your costs variable following the actual usage. Elastic load balancing, or ELB, is a perfect partner for autoscaling in turn. With ELB, you can assign a highly available service endpoint to your products and run an autoscaling pool of EC2 instances that implement your service. As autoscaling adds or removes instances from your server pool based on their load, ELB is notified of these changes. ELB constantly health checks all of the instances in the pool and balances traffic across healthy instances. Unhealthy instances are automatically replaced. All in all, you should consider cloud compute as flexible, elastic infrastructure. Next, we have networking services. With Amazon VPC, or Virtual Private Cloud, you can isolate a private, secure section of the AWS cloud for your applications. You can connect to your VPC, or Virtual Private Cloud, with an industry standard IPsec VPN connection, and you have full control over the subnets you create there. You can allocate your own IP subnet ranges in VPC, in effect securely expanding the walls over the access, routing, firewalls, rules per subnet, etc., whether they're visible towards your data center only or whether they're internal within the VPC, or if some of them are internet facing, to take an example. Next, AWS Direct Connect. AWS Direct Connect provides you with private connectivity between your data centers and AWS. You can provision, for example, a 1 gigabit or 10 gigabit dedicated connection from one of our connectivity partners. This lets you bypass the internet completely, and it can give you redundant links with known latency and bandwidth. Amazon Route 53. Amazon Route 53 is your managed global domain name service. It gives you easy self-service management of your domain names provided by our highly available network of global DNS servers. Route 53 has also advanced features such as health checking your services and automating disaster recovery failovers. Route 53 can also provide latency-based routing, directing your users to the nearest service endpoints to improve their quality of service and experience. Next, we move on to storage services. So here, I've shown you some of the basic storage services of AWS. We will start with EBS. EBS, or Elastic Block Store, are disk volumes that you can provision in seconds and attach them to EC2 instances. EBS gives you the flexibility in allocating persistent storage to your servers. You can specify the size of the volumes as well as their persistent deterministic I/O, or input-output performance. You can also mount several EBS volumes on one EC2 instance and can get even more capacity or performance by mirroring or striping across several volumes. The life cycle of EBS volumes is separate from that of the EC2 instances. You can, for example, terminate the EC2 instance, keep the EBS volume, and later reattach it back to another EC2 instance with all of the data intact. Next, Amazon S3. Amazon S3 is storage for the internet. It's designed to make web-scale computing easier for developers. Amazon S3 provides you with simple web services interface that can be used to store and retrieve any amount of data at any time from anywhere on the web. S3 stores trillions of objects and provides 11 nines of durability. What that means is that if you store, for example, 100,000 files on S3, then mathematically you may lose one file in 1 million years. S3 achieves this kind of high durability by distributing the content over several devices across several data centers within the same region. Next, Amazon Glacier. Amazon Glacier is an extremely low-cost storage service that provides secure and durable storage for the internet, for data archiving and backup. Glacier provides the same 11 nines of durability like S3 provides you, but in order to keep costs low, Amazon Glacier is optimized for data that is infrequently accessed and for which retrieval times of several hours are suitable. With Amazon Glacier, you can reliably store large or small amounts of data for as little as 1 cent per gigabyte per month, a significant saving compared to on-premise solutions. Next, AWS Storage Gateway. AWS Storage Gateway is a service connecting an on-premise software appliance with cloud-based storage to provide seamless and secure integration between an organization's on-premise IT environment and AWS's storage infrastructure. The Storage Gateway supports industry-standard storage protocols that work with your existing applications. It provides low latency performance by maintaining frequently accessed data on premises while securely storing all of your data encrypted in S3 or in Glacier. Next, we move on to database services. Databases are a fundamental part of most applications. Everyone needs them. However, managing them is traditionally very difficult and requires specialized competencies. Amazon RDS, or Amazon Relational Database Service, is a service that makes it easy to set up, operate, and scale a relational database in the cloud. It provides you with a cost-efficient and resizable capacity while managing time-consuming database administration tasks and therefore freeing you up to focus on your applications and therefore your business. RDS currently has 4 engines you can choose from: MySQL, Oracle, SQL Server, and our latest addition, PostgreSQL. Next, Amazon DynamoDB. Amazon DynamoDB is our fast, fully managed NoSQL database service that makes it simple and cost-effective to store and retrieve any amount of data and serve any level of request traffic. DynamoDB is guaranteed throughput and deterministic single-digit millisecond latency that makes it a great fit for gaming, advertisement, mobile, and many other applications. With DynamoDB, suddenly the database is no longer the bottleneck. This is a great enabler for applications to scale from small-scale development to serving millions of users in production without any architectural changes. You simply turn the dial and DynamoDB will automatically scale to meet your requirements. Next, Amazon ElastiCache. ElastiCache is a web service that makes it easy for you to deploy, operate, and scale an in-memory cache in the cloud. The service improves the performance of web applications by allowing you to retrieve information from fast, managed in-memory caches instead of relying entirely on backend databases. ElastiCache supports 2 open source caching engines at the moment, Memcached and Redis. Next, we move on to big data services. We will start with Amazon EMR, or Elastic MapReduce. Amazon Elastic MapReduce, or AMR, is a service that makes it easy for you to quickly and cost-effectively process vast amounts of data. Amazon EMR uses Hadoop, an open-source framework, to distribute your data and processing across resizable clusters of Amazon instances. Elastic MapReduce is used in a variety of applications, including log analysis, data warehousing, machine learning, financial analysis, and scientific simulations. Next up, AWS Data Pipeline. AWS Data Pipeline is a service that helps you reliably process and move data between different AWS compute and storage services, as well as on-premise data sources at specified intervals. The data pipeline helps you to easily create complex data processing workloads that are fault-tolerant, repeatable, and highly available. You don't have to worry about ensuring resource availability, managing intertask dependencies, retrying transient failures or timeouts in individual tasks, or creating, for example, a failure notification system. The data pipeline also allows you to move and process data that was previously locked up in on-premise data silos. Next, Amazon Redshift. Amazon Redshift is a fast, fully managed, petabyte-scale data warehouse service that makes it simple and cost-effective for you to efficiently analyze all your data using your existing business intelligence tools. There are no long-term commitments or upfront costs, and you can scale to a petabyte or more for $1,000 per terabyte per year, less than a tenth of most other data warehousing solutions in the market today. Next, we will move to application services, including Amazon CloudFront, Amazon Cloud Search, and Elastic Transcoder. Firstly, Amazon CloudFront. CloudFront is a content delivery service. It integrates with other Amazon Web Service components to give developers and businesses an easy way to distribute content to end users with low latency, high data transfer speeds, and no commitments. CloudFront caches frequently accessed content on the edge of your network and can significantly lower the load on your backend infrastructure while making the user experience much better. Amazon Cloud Search is a fully managed service that makes it easy for you to set up, manage, and scale search solutions for a website or application. You can easily create a search domain, upload the data you want to make searchable to Amazon Cloud Search, and the search service automatically provisions the required resources and deploys a highly tuned search index. Amazon Elastic Transcoder is a media transcoding service on the cloud. It is designed to be highly scalable, easy to use, and a cost-effective way for developers and businesses to convert or transcode media files from their source format into versions that will play back on devices like smartphones, tablets, and PCs. Next, we will talk about deployment and administration services on Amazon Web Services. Amazon CloudWatch provides monitoring for AWS cloud resources and the applications customers run on AWS. CloudWatch lets you programmatically retrieve your monitoring data, viewing graphs, and set alarms to help you troubleshoot, spot trends, and take automated action based on the state of your cloud environment. AWS Identity and Access Management, or IAM, enables you to securely control your access to AWS services and resources for your users. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. If you have an existing Active Directory server, you can integrate IAM with your on-premise Active Directory and control your users and groups centrally without having to create and manage separate user accounts in the cloud. Additionally, we recommend using multi-factor authentication when accessing your cloud accounts. AWS OpsWorks is an application management service that makes it easy for DevOps users to model and manage the entire application from load balancers to databases. You can start from templates for common technologies like Ruby, Node.js, PHP, and Java, or build your own using chef recipes to install software packages and perform any task that you can script. AWS OpsWorks can scale your application using automatic load-based or time-based scaling and maintain the health of your application. You have full control of the deployments and automation of each component. Finally, AWS Elastic Beanstalk. Elastic Beanstalk is an even easier way for you to quickly deploy and manage applications in the AWS cloud. You simply upload your application and Elastic Beanstalk automatically handles the deployment details of capacity provisioning, load balancing, auto-scaling, and application health monitoring. You still retain full control of all the resources Beanstalk deploys to run your application. To ensure easy portability of your application, Elastic Beanstalk is built using familiar software stacks such as Apache HTTP Server for Node.js, PHP, Python, Passenger for Ruby, IIS 7.5 for .NET, and Apache Tomcat for Java. So we have seen some of the basic foundational and also other application services on top of the AWS cloud offerings. Now let's explore some of the typical use cases for the cloud. First, web, mobile, and social applications. This refers to the collection of tools and technologies required to power internet applications. As shown in this sample application architecture, AWS provides on-demand access to scalable web and application servers, storage, databases, content delivery, cache, search, and other application services that can make it easier for you to build and run the apps that deliver a great customer experience. Recently, we launched a new service called Amazon AppStream. Amazon AppStream is a flexible low-latency service that lets you stream resource-intensive applications and games from the cloud. It deploys and renders your application on the AWS infrastructure and streams the output to mass-market devices such as personal computers, tablets, and mobile phones. Because your application is running on the cloud, it can scale to handle vast computational and storage needs regardless of the devices your customers are using. The second use case is AWS Big Data. So this is how the AWS Big Data portfolio looks like. We have tools like Direct Connect and Import-Export that can bring in a lot of data. We can push that data into a number of sources from S3 and DynamoDB to EMR and Redshift for analysis. Recently, we announced Amazon Kinesis, a managed service for real-time processing of streaming big data. Amazon Kinesis supports data throughput from megabytes to gigabytes of data per second and can handle seamlessly to hundreds of thousands of different data sources. The tools to support big data collection, computation along with collaboration, and sharing are all available within a couple of clicks or fully automated scripting. AWS also offers reliable and secure cloud infrastructure platform that enables enterprises to quickly launch entire enterprise software stacks from Oracle to SAP to Microsoft. Customers using Oracle, SAP, and Microsoft products can also use their existing software licenses on the AWS cloud with no additional licensing fees. Disaster recovery. Businesses are using the AWS cloud to enable faster disaster recovery of their critical IT systems without incurring the infrastructure expense of a second physical site. The AWS cloud supports many popular disaster recovery architectures, from pilot-light environments that are ready to scale up at a moment's notice to hot standby environments that can enable rapid failover. With data centers in several regions around the world, AWS provides a set of cloud-based services that enable rapid recovery of your IT infrastructure and data. We recently launched the cross-region read replicas feature that you can use to implement a geographical disaster recovery model, scale out globally, or migrate an existing database to a new geographical region. You can operate a read replica in a region different from your master database region. In case of regional disruption, you can promote the replica to be the new master and keep your business in operation. Now, let's see some of the successful strategies with which companies are getting started on AWS. Strategy number 1, cloud for development and test environments. Whenever there is a large technology shift, development and test workloads are usually the first to move. Cloud is probably the biggest technology shift we will see in our lifetimes, and we see this workload as the first workload enterprises are deploying on AWS. Customers like Lionsgate are running SAP on development and test environments. Tokyo Stock Exchange is testing Oracle apps on AWS, while Galata Chemicals are testing SAP deployments on AWS. Strategy number 2, build new applications in the cloud. New workloads are also shifting to the cloud. These are no-brainers as well. There's no legacy from which you have to migrate from. They're cheaper and less expensive on the cloud. They're easier to build and faster to deploy, and they can leverage the fault-tolerant capabilities of the cloud. You see this with customers like PBS, which runs a video streaming service on AWS, and Qantas Airlines, which has built its hotel booking application on AWS. Strategy number 3, use cloud to make on-premises applications better. The third strategy is taking applications on-premises and supplementing them with cloud resources. You see this especially in the analytics and batch processing areas. Here are a few examples. NASDAQ has a number of market operations applications. They analyze this data in the AWS cloud during the nighttime, and they move it back to their on-premise application during the daytime for the users to leverage. Or, for example, Nokia, which had a great data warehouse set up on-premise, which is hard to manage and fragile. They now run their data warehouse on AWS, where queries run twice as fast at half the costs. Strategy number 4, cloud applications that integrate with on-premise applications. The fourth strategy is essentially a reverse of the third strategy, where applications built in the AWS cloud reach back to on-premise resources. Samsung is building its Smart Hub application on the AWS cloud, but they want their financial transactions to happen on their on-premise systems. So when customers buy content from Samsung, they transition to the on-premise systems for financial transactions, and then they transition back onto the AWS cloud seamlessly for using the content. Strategy number 5, migrate existing applications to the cloud. The 5th strategy requires little more thinking. For instance, Unilever has around 1,000 websites, out of which they have migrated approximately 500 to AWS. Using AWS, they can now deploy websites in 2 days instead of 2 weeks. Bristol Myers Squibb, which migrated its clinical trial simulation platform to AWS, now takes 72 minutes for its simulation compared to 60 hours earlier. Strategy number 6, all-in. The 6th strategy is an all-in strategy where the CIO moves all their applications to the cloud. A few years back, Netflix decided to move all their applications to the cloud and become cloud native. Now we are seeing more and more companies make this decision. Netflix is a perfect example of a cloud native service-oriented architecture that is designed for automation, scalability, resiliency, anti-fragility, and data-driven businesses. That concludes the presentation. In terms of next steps, I would request you to sign up for an AWS account. You can simply go to aws.amazon.com/free and take advantage of the free tier. Now the free tier is not a free account, but it has enough credits for you to play around with our services and get your hands dirty. Trying yourself really is the best way to get a good understanding of the cloud. So go ahead, start exploring, start experimenting, and start innovating. Thank you so much for joining our webinar. I hope you found the session useful, and I look forward to seeing you the next time. So now we are ready to take questions, and I would also request in the meanwhile to please remember to fill out your feedback form and let us know how you like this webinar. Please also let us know what you would like AWS to deliver for you next. So I have a question here. The question is, can you give me an overview of what, if any, licensing arrangements you have with various providers? Example, licensing for Windows, Oracle, etc. So first off, let me start by saying that you would still have to have the licensing conversations with your existing providers. However, Microsoft and Oracle, which you specifically mentioned, have strong partnerships in place with Amazon. Microsoft, for example, has the Microsoft License Mobility Program, and you can simply visit the details by going to aws.amazon.com/windows. You can also bring your own license to the cloud, but also you can run these licenses on demand because we do have license included options for both Oracle and for Windows servers. I have another question here. It says, is there any SAP production environment running on the AWS cloud? So yes, we do have customers who are running production workloads on AWS for SAP environments. And we have several case studies that are published already for consumption on the solutions page. Let me contact you offline, and I will give you a few more case studies where you can look at how customers have actually implemented their architecture on top of AWS. So I have a question here. Is there a GPU EC2 instance for computing with GPUs? Answer is yes. We do have GPUs available. If you simply go to awsamazon.com/ec2 and go to the instance types, you'll find that there are GPU instances available for you to run on demand. And these are especially useful for video transcoding and other heavy-duty workloads. So it's a great way to grab these high-performance instances at an on-demand pricing. I have a question here. Can AWS AppStream run any type of application? For example, apps built in .NET technologies, PHP, or any other application languages? So the AWS infrastructure itself can support any x86-based application. So in specific context to the AppStream, AppStream basically is a way for you to stream your, it's a flexible low latency service that lets you stream your output to mass market devices, right? So in that sense, yes, you will be able to use your any of the underlying technologies as long as they are x86 based. It currently supports interactive streaming for applications that run on Windows, Microsoft Windows Server 2008, and client applications running on Kindle Fire OS, Android, Apple iOS, OS X, and also Microsoft Windows systems. I have a question here. Do you have case studies on customers doing big data analytics? We would like to go through on how AWS is useful. Definitely. We do have several case studies which talk about big data analytics, and we will contact you offline with some of these case studies. You can simply go to aws.amazon.com/solution/case-studies. I have a question here. We want to leverage the CloudFront to protect our static content. Can we have some useful links or case studies? Definitely. You can simply go to awsamazon.com/CloudFront and you will see several links which help you to secure your content. Just in the same vein, you can also look at a new feature that we announced. Amazon CloudFront now supports custom SSL as well, and we give you 3 options for accelerating your entire website, right? So you can either deliver content securely over HTTPS from all of our CloudFront edge locations. You can also configure CloudFront to use HTTPS connections for origin fetches. So your data is encrypted and it's end-to-end from your origin to your end users, right? I have a question here. Can you send me the link for the presentation through the chat? So we will, we already have some of these presentations available on SlideShare. So at the end of the event, when the marketing team gets back to you, they will share a link with you where you can look at resources, including SlideShare and YouTube, where we already have several webinars and content available for you. So I have a question here. Hi, this question is related to a data center move. For example, we have around 1,000 servers globally for which we work on, and tomorrow this moves to the cloud, example AWS. Would we still need to use the same number of instances, or is there a difference on how the data is set up on AWS? So a good question. Uh, First off, I would say that if you are doing a data center migration, then there are a lot of considerations for you to start with. First is the TCO conversation, as in the total cost of ownership, which talks directly to, would we use the same number of instances? I request you to review our TCO or economic center. Simply go to aws.amazon.com/economics. And here you will see that we have calculators available for you, which help you, understand what is your total cost of ownership when you actually move to the cloud. And here you would have to look at the instance types that we have, the storage, environments that we have to actually arrive at a true apples-to-apples comparison. And if you are considering such a move, please do get in touch with us offline. We will be sending you a follow-up email, and we are more than happy to work with you on the details and help you build a business case for your organization. I have a question here. Is there any services on AWS which will take a backup of MySQL daily? So I just talked about Amazon RDS, or Amazon Relational Database Service. So it's a managed service which takes care of running, managing, patching, and also backing up your database on AWS. It also comes especially for MySQL, which is one of the more mature technologies on RDS, to help you take read replicas, multiple, actually up to 5 read replicas per master database. And you would be able to load balance, for example, across these databases, and also allows you to take cross-region snapshots as well. So for instance, if you're using the Singapore region, you'd be able to take a cross-region snapshot to, say, Tokyo or US East, so you also have regional disaster recovery processes in place. So I have a question here. How can I integrate my data center with AWS? How secure is it in terms of compliance? So I talked to you about several options to actually connect to the data center. Let me quickly go back on the presentation and show you that slide. So I have that slide right now for your review. So we have several networking services, right? So we have AWS Direct Connect, which allows you to completely bypass the internet and set up a direct connect from your existing data center to AWS. You'll also be able to use a highly secure industry standard IPsec VPN. For example, if you have a Cisco or Juniper device which supports a BGP connectivity, then you'd be able to set up a IPsec VPN tunnel straight into one of the AWS regions, and then you can securely access all your resources in a private, isolated section of the AWS cloud. You can also work with virtual or open VPN kind of VPN devices, and what this allows you to do is to allocate your own IP subnet range, right? So you're effectively expanding the walls of your data center. You can also go to, by the way, it also supports statically routed VPN connections as well, not just dynamically routed like BGP. And in terms of compliance, we do have several compliances that we adhere to. So simply go to awsamazon.com/compliance. It is our, it's part of a security microsite and talks about several different assurance programs that AWS is compliant with, including SOC 1, SOC 2, SOC 3, PCI DSS level 1, ISO 27001, etc. So I don't know which compliance is that your architecture requires, but we support some of the most important regulation standards and best practices. Again, I would request you to contact us offline with your specific requirement, and we're more than happy to help you. I'd also request you to go through our security white paper. It's available at awsamazon.com/security, and it contains the details of all the security measures we take, right from physical security all the way up to the hypervisor. I have a question here. We would like to know about the structure and pricing for a complete cloud server to host our website. So I request you to go to aws.amazon.com/pricing, which actually has the list of pricing for all our products and services. You can also go to awsamazon.com/calculator, which contains our simple calculator, which can help you price out your requirements. Like we discussed before, we have several different products and services, and we also have different pricing models. So if you need any help in pricing it out, we are more than happy to work closely with you and help you look at an apples to apples comparison to the other options that you're looking at. I have a question here. If you have any question on getting started on AWS, whom should we contact to receive prompt response on help? So right after the end of this presentation, our team will send you a follow-up email, and it'll have the contact information of the AWS account managers, and the account managers would be the best people in terms of becoming the center point for you, to put you in touch with all the resources you need for any questions that you may have on AWS. So please do contact us back after you see that email. I have a question here. Would Amazon be taking care of IT support as well? I would direct you to awsamazon.com/premium support. We do have support available. We have several different tiers of support. We have business support, for example, which is a 24/7, 365 support available to you via phone, chat, email, or even live screen sharing. And your primary cases are handled by a cloud support engineer. It starts at a $100 minimum, and or 10% of your spend, whichever is higher, and it comes with a trusted advisor report as well. And it not only just gives you break-fix support, but they will also help you in terms of guiding you on your architecture on top of AWS, and be prescriptive in terms of how you can save costs, be more flexible, and also save money on AWS. So we're at the end of the 1 hour mark. So again, I'd like to take this opportunity to thank each and every one of you who've joined us for this webinar. We will be following up with a email, so please feel free to get in touch with us for specific questions, and you can go sign up for AWS at aws.amazon.com/free and take advantage of our free tier to help test our platform. Thank you and have a great day.